Assalamu alaikum. My name is Muhammad Ijlal and I am a Habib University student doing electrical engineering. Uh, I am presenting on linear motors. So basically what linear motors are, that they are electrical machines that are used to create linear motion, and they consist of two parts, that are rotor and slider. The slider is also known as the stator of this motor. The rotor is mainly made up of permanent magnets, and overall the design and is very similar to a traditional electrical motor, only the difference being that the traditional motor consists of a round stator and rotor. If they are unrolled, they can be called a simple linear motor, as shown in the picture. So a little about the history of linear motors, where Sir Charles Wheatstone, who also created the Wheatstone bridge, was the earliest engineers who worked on the concept of linear motors. After him, it was Hermann Kemper, who was the second, who brought the who was the first to bring the idea of magnetic levitation, and in 1935 he made a simple model of linear induction motor. Then there was Professor Eric Lathwaite from the Imperial College of London, who in 1940 made a full-size working model of linear induction motor. This was the first of its kind. Then in 1945, Westinghouse Electropult made a electropult using linear motors to create a mechanism that can launch aircrafts. Even today, the concept is being tested and to so that they can launch aircrafts by the in limited amount of space. So the question arises that why do we need linear motors? So the main the main answer to that can be that linear motors reduce overall power use, frictional losses, thermal losses, and other undesirable factors. As we can see in the diagram how the rotary mechanism was used to create a linear motion, and we can see that it used a lot of space, and by the help of linear motors we can eliminate the rotary part of this system and create a linear motion on its by its own. And overall linear motors are high in accuracy and precision, so there's that. So the basic working of linear motors can be that the rotor being the secondary part of the motor, while the stator being the primary side of the motor. The stator contains the coil winding, while the rotor is the permanent magnets. The primary side is provided with an AC supply which creates magnetic field, and when we change the current phase in the coils, the polarity of each coil changes. This generates attractive and repulsive forces between primary sides of the and coil, and the permanent magnets then makes the primary side to move and create a linear motion. Then there are some types of linear motors, namely being the low inertia flat linear drive, which has the properties as fast, accurate, and flat, and we can see its basic model as the first picture from the left. Then there is flat three-phase current linear motor, and it is present in asynchronous and synchronous, uh, and its picture is also present in the slide, and these kind of motors provide us with great thrust. Then there is screw thread reluctance motor, which is robust and accurate, and its simple model can also be shown in the is also shown in the picture. So we will only talk about linear induction motors here, and about its working and its applications. So about them, we say that they work on the principles of Lenz's law, and I have talked about its working, it's simple working in the previous slide, where we provided three-phase AC power supply, and the magnetic flux is induced, and due to relative motion between the traveling flux and conductors in the secondary side, current is induced, by which a linear force is produced by interacting with the flux, and this moves the primary side in the direction of the force. So there are some equations that apply on these motors, where the three equations are given, where the first equation is of synchronous speed, the second equation is of velocity traveling field pattern, and the third is of a speed of secondary in linear motor. So about the applications and uses of the linear induction motors, the main is the magnetic levitation train. Here the whole tracks of the train are the rotor of the motor, and they are all permanent magnets, while the train is the stator or the sliding part, which is made up of coils. Here it moves due to the pull and pull factor of the magnets, and the other application is of roller coaster, which is very similar to the maglev trains. Then if we put these linear motors in vertical manner, we can use them to lift heavier loads in places like mines and lifts. So there are some advancements in application of linear motors. So the two which I have mentioned, the first one being the dual axis linear motor, as shown in the picture, they are used. They are made by imposing two linear motors in XY directions, and they are used by cutting industries such as fabric cutting and metal cutting industries, and they are used due to their high accuracy and precision, and they are very fast machines. The other application which is being discussed and thought upon in recent times is the magnetic levitation, about how we can use it to lift loads and transport them. The figure shown in the picture in the slide is from a research paper, where a group of scientists made a arrangement where they were able to lift about 1.5 kgs of load by the help of magnetic levitation. They also made a controller about the whole situation. So in conclusion, we know that linear motors hold many potential applications in them, which can be used by the engineers to solve complex problems, and we hope to see them. We hope to see many more applications in the near future. Thank you very much.